running water. It's relaxing. Yeah. um, yeah, so that's running water, something you wouldn't really hear on Mars very well because, well, what water is there is frozen. This video is sort of part two of the water now topic that I'm discussing in these videos. It's not to say water couldn't be flowing on Mars. Um, Definitely a lot of evidence saying it did flow in the past, and we got lots of people dreaming up ways to terraform Mars. Whether that would take 100 years, 1,000 years, just a few years, depends on who you talk to. Um, but lots of proposals for different ways to make Mars warmer, the atmosphere thicker, uh, eventually melt the water, maybe have lakes, small oceans on Mars. You get the whole gamut. Um, Not in our lifetime, most likely. Yeah, but still nice to dream about. But what do we know about where water is now? In the last video, I focused more on sort of evidence that there is water, and most likely it's still there, and that evidence came in the form of runoff channels and outflow channels. But this video, I want to really go into more detail about where where it might be. I also talked in the polar cap video that there's most likely well, definitely water based on um, samples that we took, not samples but visual samples I should say. You probably maybe confused about what I mean by visual samples. Definitely going to talk more about that later on when we start talking about light and how we can use light to analyze what something is composed of. But I also talked in a previous video about permafrost and just barely glanced over that topic. This one I would really want to give it a solid definition of what permafrost is and how that plays a role on Mars. So yeah. So from what we can tell, there's very little water vapor in Mars's atmosphere. That's one way to consider Mars an extreme desert is that that great lack of water vapor in the atmosphere. And as we discussed in the polar caps video, frozen water is in the polar caps, maybe a few meters, maybe even a kilometer or two thick. So that's a good amount of water, definitely. Um, in terms of if you had a small colony of people there, that would be more than enough water to suit any of their needs. But compared to the Earth, not much at all. But it's thought that most of the water is probably stuck in the permafrost layer. So let's get down what permafrost is. On Earth, permafrost is not everywhere on the planet. It's really only in the cold areas, and it's basically defined as soil that's below the freezing point for an extended amount of time. I've read, that 2 years is, it needs to be at least 2 years to be considered permafrost, and it doesn't need to be water in that permafrost layer. You think of frost and you think of water, like being a layer of frost being on the ground. That's kind of water, but really it's just permanently frozen ground. Usually there's water in there because there's so much water on our planet. Doesn't have to be though. And so, for example, here's a classic example of permafrost. You got plants growing on a thin layer of soil, and just underneath is a chunk of ice here mixed in with the soil. Looks like mostly ice and just a little bit of soil, but you could also have mostly soil and a little bit of ice. But yeah, it's basically a place where the ground is frozen for an extended amount of time. On Mars, since Mars is so cold, basically everywhere just about is frozen all the time. And so none of this 2 years jive. It's basically, for thousands and if not millions, if not billions of years of just frozen. And so most of the surface, in essence, can be permafrost. But so yeah, any water in the soil will be frozen. Of course, you could heat that up. If you heat it up enough, then you could melt that water, and you would have this. So the Phoenix lander, which we landed, I believe, up in the northern part of Mars, not the southern part. I can't remember right now. I'm pretty sure it's the northern part of Mars, but definitely high up where it's like on Earth, colder. And the Phoenix lander dug some trenches, saw this, thought, well, this maybe is salt, um, but what is this? On day 20, saw these little things. Like, huh, that's interesting. Day 24, gone. Did some alien come and pick it up? No, the current thought is that based on the rate of sublimation, meaning the phase change from solid to gas, you can basically skip the liquid phase. That this is liquid water. This was ice, water ice, H2O, and since it was exposed to the air and most likely the sun at some point, I'm sure the shadow wasn't always at this point as the sun moved throughout the day, that the ice sublimated into the atmosphere, adding a tiny bit more water vapor into the little that's already there. So that was exciting news, or evidence from the Phoenix lander that, oh, maybe there's a layer of permafrost in the soil here. So pretty cool. And so, based on what we've learned so far, which, to be honest, is in the grand scheme of things very little, if we really wanted to increase the rate of evidence building from Mars, we'd really want to send people there. Hint, hint. And so, but based on what we've gained so far, this is a possible, probably one of the more accepted historical timelines for Mars. So it's thought that over 4 billion years ago, which basically, under current estimations, our solar system is 4.5 billion years old. So not long after Mars formed, it was thought that it would have been warm, and so that liquid water would have been abundant. And then, again, there's other theories as to how that water got on there was the same as on Earth, right? Was that planet bombarded with, icy comets early on, or icy big objects, and so water slowly gathered up over time? Interesting theory. And then about 4 or so billion years ago, Mars would have started cooling down for various reasons. Um, and the cooling down, it would have dropped to a temperature below freezing, and so any water on the surface or in the soil, because water would be absorbed into the soil as well, would have frozen in the permafrost layer. Maybe a lot of the water on the surface might have gone up into the poles as well. The riverbeds, basically the runoff channels we learned about in the previous water video, would have dried up. And during the next billion or so years, as Tharsis formed and the other volcanic areas, you had volcanic activity, lava flowing down. That would have heated up parts of the surface. You also would have had impacts, which would have locally heated up the surface, maybe released some lava from down below. And this would have released large amounts of water in a short amount of time, causing the really large outflow channels that we talked about. And then more recently, um, not much going on to heat up the planet anywhere. It looks like volcanic activity has dwindled to almost essentially nothing, and a lot of the big objects in the solar system have already been captured by the planets and the moons and whatnot. So impacts are much fewer these days, fewer and far between, and so essentially all the water is frozen again. Um, Estimates vary. This is big estimate. Don't take this with a grain of salt. But estimates vary that if all of the water that is currently on Mars was melted and placed above the surface, that it might cover the entire surface of the planet at an average of about 30 feet deep. Which, when you think about, it sounds like a lot. Which it's a lot of water. But when you compare it to the oceans we have on Earth, which are huge and extremely deep, still essentially a big desert planet. You get some artist renditions here of Mars, what Mars might look like if water was flowing on the planet, and you can see that the higher regions in the south would be above water. Tharsis is pretty high, but you get the lower regions in the north, and the Hellas Basin, the lowest region of the planet, and Valles Marineris and other parts would be, potentially covered in water. This is kind of a similar drawing. You got nice little clouds here, water vapor clouds maybe. But yeah. So that's what we know so far about water on Mars now. It'd be great to go there and actually dig deeper holes than a rover could dig and really test that out. It's also thought that maybe there's some geothermal areas. Uh, well, there's just thermal, like geo meaning Earth maybe, but Martian thermal areas where maybe there's actually liquid water in the under the surface, and potentially that's a place where life could thrive, maybe Martian bacteria. Yeah. But it's kind of hard to tell until we can actually, efficiently dig to those depths. But anyway, all right. So that's pretty much it for water, and I'll talk to you in the next video.